Alright, so we are now going to finish up 4.5, and these are going to be logarithmic equations that we want to be able to solve that have multiple logs sometimes, okay? And what we're going to have to use those properties. The product property, the quotient property, the power property to help us out solving these, and then using exponential rules. Okay? A few things we do need to remember. Remember the base and the number next to the log. Okay? So remember that if I have log of base times some number is equal to x, okay? Base always has to be positive, and this y value always has to be positive. X can be pretty much anything. Okay? So we're going to use a couple special rules here as we go through these. Equivalence property is one of them. Okay, if you look at number 10, we have log base 2 and log base 2. Okay? So there is a rule that basically the equivalence property, which means if I have one log on both sides with same base, and that is just one log on both sides with the same base, you can drop the logs. Okay? And case in point is this one. I have log base 2, log base 2. It's the only thing. There's nothing else with either side. They are by themselves. They stand alone. Okay? Which just basically means these logs aren't going to matter. I'm going to go 5x minus 1 is equal to 2x plus 17, and I'm going to solve, which is going to give me 3x is equal to 18 and x is equal to 6. Now, you must check to make sure when I plug 6 back into here, both of them, you get a positive value. They should be the same too, but they will be as long as they're not negative. You cannot have a negative. Okay? FYI, the log of negative 4 is not equal to the log of negative 4. Okay? That is not possible. These are not allowed to be negative. The log of 4 is equal to the log of 4. That's true, but the log of negative 4 cannot be equal to the log of negative 4 because you cannot have a negative in that value. Okay? So when I check 6, well, that's 30 minus 1, that's positive, and you just really got to check make sure it's positive. So this does work. Okay? So let's look at this next one. Log base 10, good, so I can count those out. I have x minus 7 is equal to 5 minus x. We'll solve. Okay, so this is going to be 2x is equal to 12. X is equal to 6. Hey, so I got 6 again. That's interesting. What's the ironic sense of that, right? So we're going to plug this in, but notice 6 minus 7, that's negative 1. 5 minus 6, negative 1. Okay, and remember, log of negative 1 cannot equal log of negative 1. So that means this does not work. It's extraneous. Okay, so there is no solution. Alright, so what happens if we have more than one log? Well, I can't drop logs as long as there is multiple logs. But I can, as long as they all have the same base. These all have the same base. Okay, which is good. Okay, I can condense this. Remember we talked about condensing in one of the past units? Okay, so I'm going to condense this. How do I condense this? Well, by division. So this would be the log of 3x minus 4 over x plus 1 is equal to log of 2. Now I have one log on both sides, which means now I can drop them. And I get 3x minus 4 over x plus 1 is equal to 2, and I can cross multiply and solve. So we're going to cross multiply. 3x minus 4 is equal to 2x plus 2. Okay, that's going to be x, that's going to be 6, and I check to make sure it doesn't give me a negative here. That's 7. That's going to be 18, 14, that's good. Answer 6. Now these are all coincidences that they're 6. Okay? Alright, so let's look at 13. Well, again, I have 3 logs here. I need to condense this left side. So we're going to condense it, and as addition, we're going to use multiplication. So this is going to be the natural log of x times x plus 3 is equal to natural log of 10. Alright, well now I have a log on both sides. I can cross them out. This is going to be x squared plus 3x is equal to 10. Alrighty, so now we're going to plug in. We're going to get x squared plus 3x minus 10. Solve. We're going to factor. These will all be factorable if I give you quadratics. Let's see, this will be plus 5 minus 2. X is going to be negative 5 and 2. Now remember, we do have to check. So does either one of those give me a negative inside the parentheses or next to the natural log? Well, natural log of negative 5 is not possible. Natural log of 2 is. Put the 2 here. 2 plus 3 is 5. That's okay. So it's x is equal to 2. Okay? Alright, so let's continue. Alright, so here we have 3 logs again. Well, over here, we can condense. We've done this, so this would be log base 3 of, I'd multiply those together. 6x minus 8. Okay? So, okay, this, now notice there's a log on this side, but see this 2 here? We need to bring this up as an exponent. It's got to go to this step first before I can drop anything. Because you can't have any number in front of log. Now I can drop the logs. I don't know why I put a 3 there, that's a 2. So I'm going to get x squared is equal to 6x minus 8. Get everything to one side. And we're going to factor. X minus 4, x minus 2, and x is equal to be 2 and 4. Now, do both of those work? Okay, well, let's check. Well, that's just an x right there, so but positive will always work. Does positive work here? That's 6 minus 4, that's good. 12 minus 4, that's good, so they both work. And so both solutions are good. So I have double the solutions. Alright. So, those are nice because I was able to get logs canceled out. But what happens if we have something that doesn't have a log with it? What are we going to have to deal with? So, you may have to use exponential form. Okay? Because look here, I have a log here, but I do not have a log over here. Okay? Which is going to cause us an issue. Okay? So I can't just drop logs. So what we're going to have to do is we're going to have to change this to exponential form. So remember how we do that. Okay, wrote up here again. My base, my exponent comes from over here. This is my exponent. 2 is equal to what's inside the parentheses. When I do that, notice all I have is an x left. I have 25 is equal to 3x plus 1, which is something we can solve. Okay, we're going to move the 1 over. X is 8. But again, we have to check. Does it give me a positive here? It has to be a positive, and it can't be 0. That's 24 plus 1 is 25. That is good. It does check. Okay, so we do have to still check. Okay? Alright, so now let's here. Again, here's that 2 that's standing alone over here. That's our problem because it doesn't have a log. So what we have to do is we're going to condense. That condensing row is where it comes in real handy. Subtraction means when I condense, we're going to do it by division. So this would be log base 3 of x plus 6 over x minus 2 is equal to 2. Okay, now at this point, we're going to do like we did in 15. We're going to put it into exponent form. Okay, which is going to be 3 squared is equal to x plus 6 over x minus 2. Well, I know what 3 squared is. It's 9. And we're going to have to do some cross multiply divide. 9x minus 18 is equal to x plus 6. Okay, that's going to be AX is equal to 24. X is 3. Does it check? 3 plus 6 is positive. 3 minus 2 is positive. It does check. Okay? So we're still playing this game of what can I do, what can I deal with. Okay? Now, notice here, I've got a log here, I've got a log here. This does not have a log, which means these two cannot condense. I also can't just drop the logs. So what's going to have to happen is this has to go to the other side. So we're going to have log x plus 15 plus log of x. Now, since they're both on the same side, I can condense them. Addition means multiply. So this is going to be log x squared plus 15x, because I multiplied them together, is equal to 2. So now we have to go to exponential form, because I don't have a log on the other side. Well, what base is this? This is base 10. So it's 10 squared is equal to x squared plus 15x, which is 0 is equal to x squared plus 15x minus 100. How did I get the 100? That's 10 squared. I moved it to the right. Okay? And then I can factor it. Okay? So, as I factor this, what's going to multiply to get to 100? That adds up to 15, x 20, and negative 5. Okay, and I'm going to get x is equal to negative 20, and x is equal to 5. Plug them in. Does either one of them give me a negative with the log? Well, that one sure does. That definitely does. Negative goes away. X is equal to 5. Is the only one that works. Okay? Alright, so we get down to our last example. All of this has been working the same way. Okay? So, this one's going to have some factoring skills that can help us. What we're going to do is we're going to flip a couple things around. We're going to move the 3 over. We're going to bring the log over here. So I have x squared minus 9 minus log base 4 of x plus 3 is equal to 3. I just like having positives on that side. That helps. Now, how do I condense subtraction? We do it again by division. So this is going to be log base 4 of x squared minus 9 over x plus 3 is equal to 3. Okay? Now, I notice something, and hopefully you notice something. That factors, and it has one of these. Isn't x squared minus 9 3x minus 3x plus 3 over x plus 3? Wouldn't those two cancel each other out? Which leaves me with log base 4 of x minus 3 is equal to 3. Which then, when I put this into exponent form, I'm going to get 4 cubed is equal to x minus 3. To me, that seems a whole lot easier to deal with than doing all that other stuff. Okay? So, that's going to be, what, 64 is equal to x minus 3. 67 is x. Double check, make sure it does not. 67, well, that's going to be way positive. That's going to be positive. So that works. Okay? So that concludes chapter 4, people. So if any of this confused you, 2 things you can do. 1, rewatch the video, rewind it, go back a couple times until you catch it, or come see me in the office hours. I'm not getting anybody in office hours. I don't even know if anybody's watching the videos. If you are watching the videos and they're helpful, I'd sure love for you guys to email me and say, hey, I liked the video really helped. And then again, remember, we have office hours. Now, we do not have office hours on this Friday because there's no school, but we will have office hours on Monday. Okay? And it is from 12:30 to 1:45. So, by all means, come see me and ask me questions, see how I'm doing. I'd like to see how you're doing too. We will talk to you later, and good luck.